Hello and welcome to cut. Hello and welcome to the video where we'll discuss mirror formula, sign conventions to be used while using this formula, its uses, magnification of an image, and examples of uses of this formula. So today what we try to do is basically whenever we have a mirror, let it be a convex mirror, right? And we can put an object at a distance u, and let's say it has a radius of curvature r. We can find a formula so that we can derive where the image will be formed v using u or r. So basically we are trying to derive a relationship between u, v and r. Okay, now starting with the refraction of a light on a curved surface, where we derived earlier that suppose you have a curved surface, a spherical surface like this, right? And it has a index of refraction n1 and n2 on this side, right? And we said if an object is placed at a distance u, it will form an image at a distance v, whereas this is the radius of curvature of the surface, and we derived a general formula for that, which was n2 by v minus n1 by u is equal to n2 minus n1 by r. And the sign convention was the ray of light is going like this from the object. Basically this side is positive and this side is negative here, so r is positive, v is positive, and u, because it falls on this side of the coordinate, basically u is negative, right? So we use this formula also, and we also said that the magnification in this case, which is the height of image divided by height of object, so height of image divided by height of object, which is the magnification or lateral magnification, is also equal to n1v divided by n2u, right? So this is also equal to s2 by h1, and we can find where the image will be formed and of what size or height, right? Given the height of the object, right, h1, right, we can find out how the image what will be the size of the image s2, right? So we use that formula with refracting surfaces, and now let's try and use the same formula for deriving what is going to happen in the case of reflection. Okay, so here what we're going to do is a very simple thing. We are going to assume that this is the curved surface, and now this is n1, this is n2, and our formula here is n2 by v minus n1 by u is equal to n2 minus n1 by r, right? So the r remains the same. Okay, and now when the ray of light is sort of coming from distance u, right, and then this is going to be our normal. Okay, so instead of refraction, basically it is getting reflected back. Okay, so we can write similarly for the we wrote Snell's law here, which said n1 sine theta I, which is the angle of incidence, and this was angle of refraction r, was equal to n2 sine theta r, right? Now in case of reflection, what will happen when the reflection happens? This angle is what we want, right? Now this angle is nothing but basically a negative of sine theta I, right? With the sign convention, so in this direction when the ray was going, it was positive. Now it is turned by 180, so it is negative, right? So if we put that here, basically you have n2 sine minus theta I and n1 sine theta I, which is going to be equal to n2 is going to be equal to minus n1. Sine theta and sine theta will cut. Now if we put that, so this is for reflection case, and hence we said that reflection is nothing but a special case of refraction. We also covered that part in the video when we did for law of refraction, right? So reflection is nothing but a special case of refraction when this condition is met, right? So now let's try and put this into this, and let's see what happens, right? So we are going to put this here. n2 is going to be minus n1. Okay, then our formula will become n2 will be minus n1 divided by v minus n1 by u, right, is equal to minus n1 by r. So this minus will come out, then we have 1 by v plus 1 by u, right, and again minus will come out, 2n1 by r, and this n1 will be here this side. Now n1 n1 will cut, and basically the minus will also cut. What we'll have is 1 plus v plus 1 by u is going to be 2 by r, right? And this is going to be the formula we'll be using for image formation in case of any mirror, right? So let it be any mirror, let it be a concave mirror. And now let's say we have an object at distance u. Okay, sign convention is very simple. Ray of light will come from the object, so this direction, so this side is positive, this side is negative. Now so u here is negative, r also falling on this side, so r here is also negative, and then we can use this formula to find v. Okay, in case of convex mirror, surface like this, object is on this side u, so u is negative, so this is the origin, ray of light is going like this, so this side is positive. Now r is going to fall on this side, so r here is now positive, and we can simply use this formula to find the value of v, and according to whatever value we get, we'll arrive at the sign convention. So similarly, we can use the magnification we derived earlier. So magnification was n1v by n2u, right? Now let's put this one here again. So the magnification for the mirrors will be h2 by h1, and that is going to be equal to, let's put n2 is equal to minus n1, right? So n1 v by minus n1 u, this will cut, and basically it will be minus v by u. Okay, so again recapping very quickly, and when we'll do examples will become much clearer. So basically you have this 1 by v plus 1 by u is equal to 2 by r, and we also know that the focal length of a mirror is r by 2, right? We derived that earlier, which means that it is also going to be equal to 1 by f. Okay, and the magnification or lateral magnification will be given by minus v by u, and we already know the sign conventions. So let's practice and let me show you how it works with one example here, right? And that will become much clearer. Okay, so now we have this problem which says that an object of height 0.5 meter, right? So h1 is 0.5 meters, okay, is located at 1.5 meter in front of a concave mirror. So let's draw the mirror first, right? So here's the concave mirror, and we decided we are always going to draw like that. So ray of light is going to come from the left hand side. Okay, so this side will be positive, this side will be negative. So always keep the sign convention in mind, right? So it is located 1.5 meters in front of the mirror with a radius of curvature, right? C is 2.4 meters, right? So r is positive 2.4, okay, and u is negative 1.5, right? And h is 0.5. Find the position and character of the image formed. Very easy. Now we know this formula. So we need to find v. We already know u, and we already know r. Okay, sorry, 2 by r. Okay, so using this formula, you can simply write with the correct sign convention, 1 by v, u is negative, so 1 by 1.5 is going to 2, r is positive 2.4, and basically when you solve it, so v is going to be minus 6 meters. Okay, so minus 6 meters, which means the image is going to form on this side at a further distance minus 6 meter. Okay, now let's find the magnification. Right, so magnification is minus v by u, so v is minus 6, and u is also minus 1.5, and this actually comes with a minus sign, right? So minus v by u. So this minus minus will cut, and basically what we'll have is minus 4, which means that the magnification is negative, and as per the sign convention, which means that the image is 4 times larger but inverted, right? So this is the axis. If the m comes positive, the image is on this direction, and if it comes negative, basically image in this direction, and now it is inverted. Okay, so with this magnification, now we can calculate the size of the image. The size of the image is nothing but h2, the magnification. You can write m is equal to h2 by h1. Okay, and h2 is going to be m into h1, and m is minus 4 into the height of the object is 0.5 meters. Okay, so minus 4 into 0.5, and that is going to be equal to negative. Okay, so it's going to be 4 times, but in the negative direction. Now let's move to the next problem. So you can sort of do for the concave mirror, convex mirror, always this formula will be valid. All you have to take care is the right sign convention, right? So you have to find out if the u is positive or negative, or r is positive or negative. Simply plug it in and then use the magnification formula to find the size of the image. Let's look at second problem, which says that what is the radius and type of mirror that must be used to produce an erect image of size 5 centimeter of an object of size 1 centimeter placed 3 meters from the mirror. So we do not have any information about the r, like the radius of curvature of the mirror, nor the type of the mirror. So we are going to just say that there is a mirror over here, right? And what we are given is the height of the object, which is h1, and which is 1 centimeter, and the height of the image, which is 5 centimeters. Okay, and we do not know about r, hence we do not know nothing about the mirror, but we know that it is placed at 3 centimeters from this side. So using the sign convention, the ray is traveling like this side is positive, this side is negative. We know that u is minus 3 centimeters, right? Now let's write down our formula. So 1 by v plus 1 by u is equal to 1 by f, and this is also equal to 2 by r, right? So we do not know r, right? We know u and we do not know v, so it's difficult to solve, right? So somehow we have to find a relationship between v and u, and then we'll be able to solve the problem. Now the extra information is provided, which is about the heights, right? So heights, we know the magnification, it says that the image has to be erect, right? Which means the magnification has to be greater than 0 so that the image is erect, okay, on this side. So for that, basically the m is h2 by h1, and that is 5 by 1, plugging it from here, and which is equal to 5. And we also know that m is also equal to minus v by u, right? So here it is going to be 5, and v is going to be equal to minus 5u. So now we have v in terms of u, and probably we'll be able to solve that, right? So what is our u? U is minus 3 centimeters. We are going to put it here, minus 5 into minus 3, and this is plus 15, right? So v is 15 centimeter positive, and u is minus 3 centimeters negative. And now we can use this formula to find r, right? That's what we want to find r. When we know the r, if it is coming out to be positive, we know it's a convex mirror. If it's come out to be negative, it's a concave mirror, right? So we have this formula, 1 by v plus 1 by u is equal to 2 by r. V is 1 by 15, u is negative, so 1 by 3, and is equal to 2, and r we do not know, right? So we'll leave it like that. And when we solve for it, basically r is minus 7.5 centimeters, right? So r is falling on the negative side. Looking at the sign convention again, so r has to fall on this side, which means that the mirror has to be a concave mirror, right? A concave mirror has a negative r, right? So that is going to be a concave mirror. A concave mirror with radius of curvature 7.5 centimeters. So with these two examples, we have shown that we have this formula, and once we know a couple of things about it, right? So we can always find a relationship between them, right? So 2 by r is also equal to 1 by f, and m is also equal to h2 by h1, which is also equal to minus v by u. And with this fundamental formula, right, we can solve any kind of questions related to mirrors, their positioning, their object, their sizes, etc. So this was a couple of examples. We'll do more problem set in the future video. If you want to watch more videos, you can go to deep dive physics.com. You can register, then you have a very structured playlist, and you will be able to proceed from one by one. And we also do personal tuition classes for IIT, JEE and NEET. So if you are interested, please get in touch and we'll be happy to help.